Hello, geometry. So today what we're working on is the week 7 notes because we're now in week 7, or at least the second half of week 7, I guess. And we can see the week 7 notes are only 2 pages long, so they're pretty good. And we're just gonna be covering the first page today. Not gonna be difficult at all. It's some pretty simple stuff, but stuff on Monday is what I'm a little bit more concerned about. But this stuff today, pretty simple, so shouldn't be hard at all. Make sure you complete the activity I'm going to leave in Schoology as well. So today we are learning about the triangle inequality theorem. And the triangle inequality theorem says that the sum of any two side lengths of a triangle is greater than the third side length. So, like in this triangle here, that means that measure of that side AB plus the side BC has to be greater than AC, or BC plus AC has to be greater than AB, and AC plus AB is greater than BC. All three of these have to be true. And when we do problems like this, all three of the inequalities have to be true, but you only need to show the sum of the two shortest sides are greater than the longest side to prove it's a triangle. So you don't need to show all three inequalities. You just need to say, or like add the two shortest sides and then see if they're greater than the longest side. And show that 3 lengths cannot be the side lengths of a triangle. You only need to show that one of the 3 triangle inequalities is false, which is basically what I just said. Okay, so let's look at these example problems. So determine if a triangle can be formed with 3 given side lengths. So all we're doing is looking at these side lengths for these example problems and determining if we can make a triangle with them. So I'm going to take my 2 shortest sides. So looking at these 3 side lengths, my 2 shortest sides are going to be the 12 and the 4, because 17 is greater than both those numbers. And I'm going to say 12 plus 4 should be greater than 17 if this forms a triangle. 12 plus 4 is 16, and that should be greater than 17. But 16 is not greater than 17. Therefore, this is not a triangle. On the next problem, I'm going to identify my 2 shortest lengths, which are going to be the 24 and the 8, because they're both smaller than 30. And I'm going to say 24 plus 8 should be greater than that third length, 30. And 24 plus 8 is going to be 32. And that should be greater than 30. So yeah, 32 is greater than 30. Therefore, we'll say, yes, triangle. Yes, it's a triangle, or you can make a triangle with these side lengths at least. And again, you can't just pick any 2 random sides. It has to be the 2 shortest sides adding must be greater than the third side, the longest side. And the reason we only have to show one inequality is because just looking at this, I can automatically tell that 24 plus 30 has to be greater than 8 because both those numbers are already greater than 8. And 8 plus 30 has to be greater than 24 because 30 is already greater than 24. So even without adding the 8 on to either one, I already know that the inequality is going to be true. But I don't know if it's going to be true when I add the 2 shortest lengths together. So that's why I only have to show one of the 3 inequalities. So part C, we have this triangle with the side lengths 5, 5, and 10. And since it has 2 of the same side lengths, I know it's an isosceles triangle, if it is a triangle. And we're going to add these 2 shorter lengths together. So I have 5 plus 5 greater than 10 well, let's see, 5 plus 5 is 10, greater than 10. But it says greater than. It doesn't say greater than or equal to. It just says greater than. So 10 is not greater than 10. 10 is equal to 10. Therefore, this is not a triangle. And I'm going to add a part D on here. So here's D, and this is going to be another isosceles triangle. Let's say its side lengths are 2, 3, and 3. So we want to take the two shorter sides and add them to the third side. But since there are two of the longest sides, since two sides are both 3, and 3 is the largest number I see here, I'm just going to take the shortest side plus one of the others. So I'm just going to take the 2 and the 3. So I'm saying 2 plus 3 should be greater than 3. And 2 plus 3 is 5, which is greater than 3. So yes, this can be a triangle. So the triangle inequality theorem, pretty simple, not too difficult. The other part of the triangle inequality theorem that we might see, or the other type of question, it says two sides of a triangle have the measures 7 centimeters and 14 centimeters. Find the range of possible measures for the third side. So we need to figure out exactly how long that third side could be. So to determine the answer to this, all we're going to do is take the two sides and add them together. So I have 7 plus 14, which equals 21. And then I'm going to subtract them. So 14 minus 7 equals 7. You don't want to do the smaller side minus the larger side. You want to do the larger minus the smaller every time, because we're not working with negative side lengths here. I've said that before. So the largest the side length could be is 21. The shortest it could be is 7. And actually, it can't actually be 21 or 7, because then it would just be a straight line. But it has to be between 21 and 7. It could be 7.0001 or 20.999. So we're going to say 7 is less than the third side, which is less than 21. So the third side is somewhere between 7 and 21. And if it's like an actual triangle and that side is given, they give you like the name of the side. If it's like AB or something, you would say AB instead of the third side. But since in this problem there is no name for it, I'm just calling it the third side. Okay, the other thing we're learning today should also be pretty simple: side and angle relationships in triangles. So if two sides of a triangle are not congruent, then the larger angle is opposite the longer side. And if two angles of a triangle are not congruent, then the longer side is opposite the larger angle. So that might seem like confusing at first, but let's look at it because it's not too bad at all. If AC is the longest side, so here's AC in that triangle, then blank is the largest angle. So let's see, I'm looking at my triangle. AC is here, and the angle opposite that side, which is this angle B, would have to be the largest angle. So since AC is the longest side, then B is the largest angle. Then it says if AB is the shortest side, so here's AB, then the angle opposite that, which is going to be C, is the smallest angle. So the shortest side is always opposite the smallest angle. the largest side is always opposite the largest angle. So if angle B is the largest angle, so again, there's B, then opposite that is this side AC is the longest side. If angle C is the smallest angle, then the side opposite that, which is AB, is the shortest side. So the smallest angle is always across from the smallest side. Largest angle is always across from the largest side. So problems we might see with these side angle relationships would be something like this. So it says, order the measures of triangle ABC from least to greatest, or the angle measures. So they don't give us any angle measures, but they give us the side lengths. So I want to look at the side lengths here. I see 29, 44, and 50. 29 is the smallest of those numbers. So across from that 29 is B. So if I'm ordering it from least to greatest, I'm going to say the measure of angle B. And I'm using that M because it specifically asks for angle measures. And then I will say is less than and the second smallest side would be that 44, because 44 is less than 50. And that 44 is across from this A, which is less than the measure of angle A, which is less than the measure of angle, well, C, because C would have to be the largest here, because it's the only one left. And also because it's across from that 50 feet. And I know that typing these less than symbols and angle symbols can be difficult if you guys are doing this in Cami. No worries. You could also just instead of these less than symbols, you could just use commas to separate them. And lastly, hold on, what's going on? Never mind. Okay. And lastly, it says order the side lengths of ABC from least to greatest. So even though we could probably eyeball this and have a good prediction, we still need to figure out the third angle. We don't know what it is yet. So I know that my two angles here are 83 and 62, and I know because of that triangle sum theorem that the interior angles have to add up to 180. So I'm going to say 62 plus 83 plus, we'll call it angle C, equals 180. So 62 plus 83, I'm combining my like terms. That is going to be 145 plus angle C equals 180. I'll subtract 145 from both sides. So that gives me angle C equals 35. So right here is 35 degrees. All right, so now that I know all three of my angle measures, I can determine the side lengths from least to greatest. So the smallest angle measure here is that 35, and across from the 35 is side AB. And AB is going to be less than, let's see, the middle angle measure here is going to be the 62, because 62 is less than 83. And across from that 62 is BC. And BC is going to be less than The largest angle here is that 83, and across from that 83 is AC. So AC, and that would be our answer to number 4 here. And that would be the entire notes that we're taking today. Like I said, it's pretty simple. It's just like looking and determining, oh, what's across from this smallest side, or for the first part, just adding stuff together pretty much, determining if it's greater than or less than. It should not be too difficult. But if you do have any questions, please let me know. But that is today's notes. I will see you guys on Tuesday. Make sure you watch Monday's notes as well, though.